All right, let's talk about a tool that's completely shaking up how we all interact with data. It's called RapidMiner, and its big promise is that it can unlock the power of machine learning, all without you having to write a single line of code. Pretty bold claim, right? So, to really get why a tool like RapidMiner even exists, we've got to take a step back and look at the big picture. We're right in the middle of this massive shift in technology, and people are calling it the no-code revolution. And this quote, it just perfectly sums up the problem, doesn't it? We all hear that data is the new oil, and we've got tons of it. But turning that raw, messy data into something actually useful, well, that's the really, really hard part. For the longest time, getting those insights meant you had to be a coding wizard, fluent in languages like Python or R. It was a massive barrier for most people. But now, this no-code way is flipping the script. It's visual, it's intuitive, it's all about dragging and dropping. It's opening doors for everybody. So what exactly is a no-code platform? Well, think of it like a visual programming environment. It lets you tackle really complex jobs by connecting ready-made blocks together instead of writing out instructions line by line. It's all about making powerful technology accessible to more people. Okay, so we've got the whole no-code revolution down. Now, where does RapidMiner fit into all of this? What does this platform actually do? Let's dive in. The simplest way to put it is that RapidMiner is your all-in-one data science workbench. It's built to handle the whole process, from getting your data ready to building predictive models and even getting them out into the real world, all from one visual place. Now, this is what I find really cool. Who is this actually for? It's not just for the PhD data scientists. No, it's designed for business analysts, for researchers, for students, really for anyone who's curious about data. Their whole mission is to make machine learning accessible to everyone. And the fact that they have a free plan, that makes it incredibly easy to get started. So how does this thing actually work in practice? Well, the best way I've heard it described is like playing with digital Legos. You're not writing a bunch of instructions, you're visually snapping together these data blocks to build a process. The whole philosophy just boils down to this super simple 4-step flow. First, you get your data in there. Then, you start adding what they call operators, which are just pre-built tools for basically any task you can think of. You connect everything together to create a workflow, and then you just hit run to see what you get. Okay, that all sounds great in theory, right? But let's actually see it in action. Let's pretend we want to build a common model called a decision tree, maybe to predict which customers might cancel their service. We're just going to walk through how these blocks would fit together. So picture this. You open up RapidMiner. Over on the side, you've got your repository. That's just where all your data files live. Below that is your operators. That's your entire toolbox. And that big empty space in the middle, that's the process canvas, your main stage. First thing you do, you just grab your customer data from the repository and drag it right onto the canvas. Easy. Then, you head over to your toolbox, find the decision tree operator, that's the brains of our model, and you drag that onto the canvas too. The next logical step is to connect them. You literally draw a line from your data to the decision tree. Then you connect the model to the final result. You hit that big blue run button and, whoops, an error. But wait, this is actually a really good thing. The system isn't just crashing, it's telling you exactly what went wrong. It says the input doesn't have a label attribute. Okay, what on earth does that mean? Well, here's the key. We forgot to tell the model what we wanted it to predict. In data science, the thing you're trying to predict is called a label. And of course, there's an operator for that. It's called setRole. So the fix is super simple. We go back to that toolbox, grab the setRole operator, and we just slot it in right between our data and our model. We tell it which column is our target, connect all the blocks in the right order, and we hit run again. And bam, just like that, it works. This perfectly shows the power of the platform. We just built a whole predictive model with a few clicks, zero code, and now we have this amazing visual decision tree ready to go. Okay, that seems almost too easy, right? And it is incredibly powerful. But like any tool out there, it is not a magic wand. So let's get real and take a balanced look at the actual pros and cons. On the plus side, the benefits are huge. Accessibility is number one, for sure. It opens this world up to so many people. That leads directly to incredible speed for testing new ideas. But on the flip side, there are some real trade-offs. A lot of users say there's a surprisingly steep learning curve to really master it, and you do lose some of the deep customization you'd get with pure code. But maybe the biggest risk
It's so easy to build a model that you can do it without really understanding why it works, and that can be a dangerous trap.
So, after weighing the good with the bad, what's the big takeaway? Where do we stand on tools like RapidMiner? It's so easy to get swept up in the marketing buzz for new tech, right? So let's just cut to the chase. Is this thing just hype, or is it a true, genuine game changer? The verdict seems to be that it absolutely is a game changer, but there's a huge if attached to that. Yes, it democratizes AI. Yes, it dramatically speeds things up. But, and this is the big one, it's not a replacement for critical thinking. To use it well, you still need to have a solid understanding of data principles. And that really gets to the heart of it all. The point of a tool like RapidMiner isn't to make data scientists obsolete. Not at all. It's about empowering everyone else, the analysts, the managers, the students, to start thinking and working just like one. And that leaves us with one last question to chew on. As these no-code tools get even smarter and more automated, what does it even mean to be a data scientist in the future? Will it be less about coding and more about creativity and strategy? What do you think that future looks like?